What's up everyone? So in this video, we're going to be looking at how to do primitive counting for this particular problem. I'm going to walk you through step by step through the process of how to go about this, right? So let's start off by analyzing the first line of our method, which is line 2. Immediately you see that we're creating a new integer array and we're assigning it to some value, right? So far we have two operations for the declaration and the assignment. But then you're also creating a new integer array of n blocks, right? Picture if n was 3, you'd be creating an integer array that looks like this. And it would take you a total of 3 CPU cycles to create this, right? So for line 2 already so far we have how many? 2 plus n operations. We have the declaration, we have the assignment, and we have the creation of these two. We have the creation of this integer array, right? So that's what we have so far for line 2. So we have 2 plus n. I'm going to write it at the bottom, right? And then we start analyzing our for loop structure. Again, we're going to be creating a new value. Int I is equals to 0. This is going to count as 2 operations, right? So already we have 2. Now we need to check how many times is this comparison operator going to run. And how many times will the for loop, the rest of the structure of the for loop that follows, how many times is that going to run? And the basic idea is that as long as whatever this is true, as long as this returns true, the for loop structure is going to run. So anything beyond this semicolon is going to run only if this is true, right? So pause and make sure you understand that before we continue. So with that in mind, let's analyze how many times this is going to run. I'm going to create an example value of n is equals to 5. Let's say n is equals to 5, right? And I'm going to count how many times the comparison operator runs and how many times the increment operator runs. So let's say I plus plus. So your I value is going to start from 0, 1, 2, 3, 4, 5, 6, and so on. So we can trace these numbers over here. We have 0, 1, 2, 3, 4, 5, let's say 6, right? And we want to keep track of where we're going to stop. So we're initially going to start at 0. I is going to have a value of 0. Now you're going to compare. Is I less than 5? In this case, yes, this is true. I is less than 5. And you just performed the comparison operator and found out that is true, right? So given that this statement is true, this statement is going to execute. And now that you've incremented the value of I, the next value of I will be 1. You do the next thing. Is 1 less than 5? You're going to say, yes, this is true, right? And at this point, you've compared I to n, meaning you've performed this operation again. And you found the value of this operation to be true. So you proceeded to increment I++ and run the rest of the for loop. So whenever I++ runs, the rest of the for loop also runs. So bear that in mind, right? So at this point, you've incremented the value of I. Now I holds the value of 2. Let's move this. Now I holds the value of 2. Is 2 less than 5? We're going to say, well, yes, it is less than 5. You've executed the comparison and you found the value to be true, so you're going to increment I again. right? And again, now the value of I is 3. Is 3 less than 5? Well, yes. So you've executed the comparison operator and you found the value to be true, so you decided to execute the increment operator with the rest of the for loop. And we're going to do the same thing here and find out what happens. Let's say I has the value of 4. Is 4 less than 5? Well, yes, that's true. 4 is less than 5. And you've already executed the comparison, and since the value is true, you're also going to execute this statement below, right? And now that you've incremented the value of I, now I holds the value of 5. Now you're going to compare again. You're going to ask yourself, is 5 less than 5? You're going to say, no, this is false. But you've executed the comparison. However, you did not execute the rest of the for loop structure, right? You did not execute I++ because anything beyond this semicolon here is not going to execute if whatever this is evaluates to false, right? And so to sum this up, let's sum all these up, right? You'll see that we had a total of 1, 2, 3, 4, 5, 6. We had a total of 6 for this one, and we have a total of 5 for this one. And if we put this in terms of n, we have n plus 1, and we have n, right? So we already know how many times these statements are going to execute. We know how many times this statement is going to execute, this whole block, and how many times this whole entire block is going to execute, right? And we have to be careful here. We have to take into account how many operations do each of these two blocks have. So let's compare these two blocks. Am I recording? Okay, I'm still recording. Okay. We need to count how many operations are here. So in this case, we only have one operation. Do you see? We have one operation. So given that it's one operation, we have 1 times however many times we calculated here, which is this value n plus 1. So we have 1 times n plus 1, right? Plus, how many operations is this little block? We'll see that this is an increment operation. We count this as 2 operations, right? The I++. So you have 2 operations running how many times? Well, we've calculated that they run n times, right? So you have 2 times n right there. So for line 2, we had 2 plus n. For line 3, we have a total of 2 plus n. Let's say 2 plus 3n. Let me simplify this. We have a total of what? Two plus 3n plus 1. So we have 3n plus 3 for this one. We have 3n plus 3. Right. 3n plus 3, and this makes sense. Just simplify this and make sure we get the same answer. This is for line 3. We have 2 plus n plus 1 plus 2n. Yeah, we have 3n plus 3. So that was it for line 3. Right? We have successfully calculated line 3. Let me clean this up a bit so we can continue. Now we're going to look at line 4. Right? And we're going to keep in mind that line 4 is within the for loop structure. So you have to bear that in mind. Let's count how many operations we have here. We have this indexing operation, which is one operation. And we have this assignment operation. Right? And we're not creating the value of part sum because it's already created above here. So we don't have to count the initialization again. So in total, we have how many operations? We have 2 operations. Right? And since the two operations are within this for loop structure, we need to ask ourselves, how many times will these two operations run? And having that in mind, you'll know we've already calculated how many times this outer loop is going to run. We're going to have 2 times n. It's as simple as that. So for line 4, we have 2 times n. Let's look at line 5 over here. We're creating this integer j is equals to 0. So we have the declaration and the initialization. So that's 2. Right? That's 2 operations. But how many times will this operation run? Because you have to be careful and keep in mind that you're within another loop. So you have to keep in mind that it's going to run however many times the outer loop is going to run, which we already said is 2n. Do you see? So for this line, it's going to be 2 times n. And you're going to do the same thing. We're going to do the same analysis for this part, like we did over here to the side. Right? So let's do it separately. I'm going to move this to somewhere else in case we need to reference it at any point. So let's move this away like that. So we're going to do the same analysis. So quickly, we're going to jot down j less than or equals to n. That's the operation. We're going to keep track of how many times it runs. And at the same time, we're going to keep track of how many times this j++ runs. Right? And a small little example is to give ourselves a value. Let's say n is equals to 3 this time. Right? So you can pick any example value just for you to get the hang of this. So j is going to start from 0, 1, 2, 3, 4, 5, and so on. Right? Our starting value is going to be 0. Now we're going to ask ourselves, is j less than or equals to 3? Well, yes, this is true. So by now we've executed the comparison and the value evaluated to true, meaning execute the rest of the for loop. Right? Including the j++. Now that you've incremented the value of j, it now holds the value of 1. You do the same thing. Ask yourself, is 1 less than 3? Less than or equals to 3? Well, yes. And by this time you've executed the comparison and you found the value to be true, so you executed the rest of the for loop, including the j++. So just bear that in mind. I'm not going to repeat this anymore. Okay, we're going to do the same thing for 2. Is 2 less than 3? Less than or equals to 3? Yes, that's true. Execute this, right? Now, j holds the value of 3. Is 3 less than or equals to 3? Yes. Because 3 is less than or equals to 3, right? So we've executed the comparison over there, and we've executed the increment over there. Now j holds the value of 4. You want to ask yourself, is 4 less than or equals to 3? Well, not really. So we've executed only the comparison operator, but not the rest of the for loop. Right? Meaning if we were to tally all these up, if we were to count these, we have 1, 2, 3, 4, 5. Let's say 5. And this time we have 1, 2, 3, 4. We have 4 right there. And if we write these numbers in terms of n, you have n plus 2, and you have n plus 1. Right? So let's bring it back together here. I'm going to shift it a little bit. Shift this a little bit. I'm going to bring it back here. So we said this focus is going to run how many times? N plus 2 times. So we have plus. How many operations is this? It's just one comparison operator. So we have 1, times n plus 2, right? And how many operations is this fork? That's going to be 2 operations, right? So you have 2 operations running how many times? Let's clean this up. 2 operations running n plus 1 times. So you have n plus 1 times, right? But at the same time, you have to be careful here. You have to keep in mind that this loop structure, well, let me actually highlight this. You now have to keep in mind that this is going to run however many times, right? Let's say we already calculated it. We said it's going to be n plus 2 times. It's going to run n plus 2 times. But it's within another for loop structure, which runs n times. So you have to also keep that in mind. So we already did that for the j is equals to 0 parts, where we said it's 2 operations, but those 2 operations are going to run n times. And now we have to do the same thing for the rest of the operations, right? So let's take care of that. What does that look like? Let's see what does that look like. So it's as simple as saying whatever values you found for this, you're going to multiply them by n. Let's say multiply by n here. And you're going to multiply this one by n as well. So I'm going to replace this one here with n. Right? That will give us a total for this line. So for line 5, we have what? For line 5, we have this expression. I'm going to leave it to you to simplify this. Right? We have line 5, we have that particular expression. Right? Now we're going to have to keep in mind that this innermost part is within 2 for loops. Right? And so let's calculate how many operations are here. Let's quickly do this. You have your indexing operation right there. We'll count that as 1. You have your increment operator over there. That's 2. You have your assignment operator. That's 3. You have another indexing. That's 4. So this line you have a total of 4 operations, right? If you were to look at this line in isolation. Now, if you look at this line in its context, you'll see it's within this loop and within that loop, right? And so let's look at it from this perspective of this loop. How many times will this loop run? Well, we calculated it over there. We said this loop is going to run n plus 1 times, right? So you have 4 times n plus 1, right? And how many times will this whole entire loop run? Meaning, how many times will this outer loop run, the outermost loop? It's the value we calculated there, which is n. So having that in mind, we're going to multiply it by the value of n there, which will give us a total of 4n squared plus 4. You have 4n squared plus 4 for line 6. So we have line 6, we have 4n squared plus 4, right? And then lastly, you have your return statement. Let's look at your return statement. We're simply returning a value. We're going to assume that this is one operation. So we have line, is it line 9? We have line 9 as 1. Now your final Tn expression is going to consist of you summing up all of these right? And I'm going to leave you to do that. And in the end, you should get a final answer of big O of n squared. Right. The primitive counting approach is more involved, and it involves a lot of planning and mathematics, but if you've mastered this approach, if you practice this approach, you'll be on your way to understanding any primitive counting problem, right? Even though even if it could be a different problem, not exactly the same one, you'll be able to analyze it with this approach, right? So I hope that makes it clear, and I hope this video helped you in some way. If it did, consider clicking the like button and subscribing for more. And as always, thanks for watching and see you in the next one. Peace.